Let's clear up some confusion about what the anion gap really is. How can an anion gap exist if plasma is electrically neutral? These appear to be conflicting concepts, but they actually work together. Let me show you how to make sense of it. The anion gap is the difference between cations and anions in plasma. A normal gap is anywhere between 4 to 12 milliequivalents per liter. Plasma, which is the liquid part of blood, is electrically neutral. That means there is an equal number of cations and anions. So, do these concepts contradict each other? They don't. The anion gap is a calculated value. In reality, there is no gap. It is calculated using only the predominant electrolytes. Sodium and potassium are the cations, and bicarbonate and chloride are the anions. We do this because those particular ions are by far the most predominant ions in plasma. They are the ones that are considered to be the most critical ions for maintaining homeostasis. These are the select electrolytes used in the calculation of the anion gap. Now notice the relative concentrations of these predominant ions. The cation concentrations way exceed those of the anions, and this is why our anion gap, our calculated anion gap, is always positive. If we were to perform the anion gap calculation using all the cations and all the anions in the body, the value would be 0. The true anion gap is actually 0. Because electrical neutrality must exist in plasma, the 4 to 12 milliequivalent per liter value that we calculate using the select electrolytes is both the difference between the concentration of selected anions, but also the concentration of those other anions that must exist to achieve electrical neutrality. They're the forgotten anions in the equation. Really, the calculated anion gap must be understood from the context of plasma neutrality. The concepts actually go hand in hand. Check out the unit on anion gap called Filling in the Knowledge Gap at pharmacology.com.